Hello, good morning viewers. Let us find a solution to this interesting geometry puzzle. We are given a square ABCD with an inscribed sector MEF, and we are asked to find the area of the shaded region. To find the area of the shaded region, you have to first of all find the area of the entire square. Then you take away the area of this sector, likewise the area of these two right angle triangles. Alright, now let us find the area of the square first. Remember, area of the square is length squared, and the length of this square is 16 centimeters. So the area of a square is length squared, where the length is 16. So this is equal to 16 all squared, and 16 squared is 256. So this is 256. The unit is centimeter squared. So this is the area of the square. Coming back here, we have a sector and we have two right angle triangles. First of all, let us find the area of the two right angle triangles. Then later on, we come back to the sector. Remember that the area of a triangle is given as half the base times the height. And the height is AM. And how can we obtain this AM? AM is just half of the length of this square, because M is a midpoint. Why is it a midpoint? Because the two legs of this sector are nothing but the radii of the cycle. And remember, they are always equal. This implies that AM is half of 16, which is 8 centimeters. If it is 8 centimeters, we can now use 8 and 6 to find the area of this right angle triangle. And because of this M as a midpoint, it implies that the two right angle triangles are exactly the same. So we can just use 1 and multiply by 2. So the area of a triangle, which is half the base multiplied by the height. And this is equal to half the base is 6 and the height is 8. Half of 6 is 3 and 3 multiplied by 8 is 24. And therefore this is equal to 24 centimeter squared for one of the right angle triangles, because we are dealing with 2. Therefore we can multiply this by 2. Therefore for the two triangles, it will be equal to 2 multiplied by 24, which is 48 centimeter squared. Now this is the area of the two triangles. What is left for us to find is the area of the sector. To find the area of the sector, we take the angle subtended by the sector, divide by the total angle of the cycle, 360. Then we multiply by pi r squared. This implies that we have to find this angle and also the radius. Let me start by finding the radius. The radius is nothing but ME, which is the hypotenuse of this right angle triangle. Therefore, to find the hypotenuse of this right angle triangle, we can apply Pythagoras rule. Provided that this is our angle, we say that the hypotenuse squared is equal to the opposite squared plus the adjacent squared. And this implies that ME, which we are looking for, is nothing but the square root of AM squared plus AE also squared, where AM is 8, so we have the square root of 8 squared plus AE, which is 6, we have 6 squared. And 8 squared is 64, 6 squared is 36. If you add them together, you shall obtain 100. So this is equal to the square root of 100. And finally, you can see our radius, which is ME, is nothing but 10 centimeters. Next, let us find the angle subtended. And one thing you should remember is that angle on the straight line is 180 degrees. If it is 180 degrees, if you take away these two angles from 180 degrees, you shall obtain this required angle theta. So let us find this angle alpha by applying sine ratio. And the sine alpha is equal to opposite divided by hypotenuse. And this hypotenuse, remember, is equal to 10 centimeters. So sine alpha is equal to the opposite, which is 6, divided by hypotenuse, which is 10. And to find alpha, we can take sine inverse of both sides. Therefore, alpha is equal to the sine inverse of 6 divided by 10. And alpha is approximately equal to 36.9. So we have 36.9 degrees. And remember that we are dealing with 2 alpha because the 2 right angle triangle are exactly the same. Therefore, if we should multiply alpha by 2, we have 2 alpha. This is approximately equal to 73.7 degrees. And to obtain theta, which is the angle of the sector, we can take away 2 alpha from 180. Therefore, theta is equal to 180 degrees minus 2 alpha, which is equal to 180 degrees minus 73.7. And theta is approximately equal to 106 degrees. So now we can use this theta and radius to find the area of the sector. So therefore, the area of a sector is equal to theta divided by 360 multiplied by pi r squared. Theta is now 106. So this is equal to 106 divided by 360 multiplied by pi, which is approximately equal to 3.1415, multiplied by radius squared, which is 10 squared. So let me multiply everything directly. This is approximately equal to 92.5 centimeter squared. So 92.5 is approximately equal to the area of the sector. Finally, to find the area of the shaded region, which is this, all we have to do is to take away this area and these 2 areas. Area of shaded region is equal to area of square minus area of the 2 triangles, then minus the area of sector. And this is equal to, remember that the area of the square is 256 minus area of the 2 triangles. Let me find it here. Area of the 2 triangles is 48. So we have 48 here. Then minus area of the sector, which is 92.5. So we have 92.5. This is equal to 115.5 centimeter squared. So this is the area of the shaded region approximately. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.